Okay, so like I told you, I'm going to go back to 7.4 because you need to know matrix arithmetic in order to be able to understand the stuff in here. And so matrices come into question when you've got systems of linear equations. Okay. So right here is a system of linear equations. Okay, and my claim to you is it can be written in matrix form like this. Whoa. Okay, so can you copy, excuse me, copy this down and I'll go over it. Okay. All right, does everybody recognize that this is a matrix? Yeah. What's its order? 3 by 3. And this other dude? 3 by 1. Can I do this multiplication? Yeah. And what should my result be? 3 by 1. Nice. Good. Okay, so that's 3 by 1. So let's do the multiplication. Okay, so what do I mean by that? I mean that I'm going to go this times this, which gives me x plus 0y minus 3z got to be equal to negative 2. Is everybody with me on that? Yeah? And then the second one, okay, you're going to get 3x plus y minus 2z equals 5. So everybody with me on that? Right? And then the last one is going to be 2x plus 2y plus z equals 4. That's the equations you started out with. You guys with me on that? Yeah? So you can see that you can take a linear system of equations and put them in matrix form, and then do a lot of pretty fancy matrix arithmetic with it, and get answers out of there. Okay, so that's why this is a really powerful technique here for solving linear systems. So what we're going to do is we're going to use Gaussian elimination, but you're going to use matrix notation. Okay, so we're going to do it a la matrices instead of that. Why am I using this? There we go. Nice. Okay. Yeah, Leila Garcia from 5th period, I think, had pity on me and got me a mouse, which, you know, I've had for over a month. I've just been too slow to put it in. And I just got really frustrated yesterday and said, screw this, I'm going to do it. So yeah, it's really wonderful. So, hey, Leila, thank you. Solving by Gaussian elimination. So what you want to do is you want to do some massaging on the matrices. Okay, I'll show you what that means. And put it in row echelon form. So here's your matrix in row echelon form. Okay, and then you know that you can back substitute out of this guy, because from here you know that z is equal to 2. Does everybody see why? Yeah? Does everybody see why z is 2? Yeah? Okay, if you were to do the matrix multiplication on this guy, you take these two guys and you did the matrix multiplication, do you guys all see that you would get x plus 0y minus 3z? And the other one is going to be 0x plus y plus 7z. And the last one would be 0x plus 0y plus 2z. Oh, sorry, 1z. And that's going to be equal to minus 2, 11, 2. And yesterday we talked about two matrices being equal if and only if the corresponding elements were equal. In other words, if and only if this was equal to that. So that's why z is equal to 2. Does everybody see that? And then from the next equation, you know that y plus 7z is got to be equal to 11. You take this z, you shove it in here, and you get y is equal to negative 3. Is everybody all right there? Okay. Then can you spend a minute finding x for me using this technique? What is this technique called? What's the name of this technique? Back substitution, because you're going backwards from z, y, x. Okay. That's why it's called back substitution. So spend a minute and get me x, please. Anybody? Sorry? 4? Let's see. Z is 6, negative 6. X equals 4. Is everybody with me on this? Yeah? So your answer should really be written as an XY pair, or triple rather. XYZ, 4, negative 3, 2. Okay, your answer should be written as an XYZ triple. Now, unfortunately, you know that life is not that easy. You do not get a system of matrix equations that's already reduced in row echelon form. Okay, so we got to do massaging to it. Now, the massaging on this thing here is very similar to what we did in Gaussian. It's a little bit better in the sense that you do not have to carry x, y, z's with you. You do not have to carry x, y, z's with you. So your first step is to get what's called an augmented matrix. Okay, it's called an augmented matrix. So take a look at the equations that I gave you, and what I mean by that is take a look at that. Okay, that was your first set of equations that you had. Okay, and create this matrix, which is called an augmented matrix. Does everybody see how you're augmenting it? Augmenting it means making it bigger, basically. Sorry? Eileen, what did you say? Nothing. Oh, I thought you said something. How do you get the augmented matrix? Yeah, Henry? So what you do is you take this matrix, okay, right, this one here, and tack on this one here. You guys with me on that? Okay, so then now you've got a matrix whose order is what? What's the order of this matrix here? 3 by 4. Okay? And what you've got to do is you've got to make moves on this matrix so that this all becomes row echelon form. In other words, this is a 0. This 3 becomes a 0.